Hello everyone. I've wanted to use this particular formula for my tutorial, but I realized that these two formulas have exactly the same function. They are meant for finding the variance of a given distribution. We have the summation of xi's, all the xi's, minus x bar whole squared divided by n. It is equivalent to the summation of xi squared divided by n minus x bar whole squared. I'm going to explain every single term. Let's start with xi. What is xi? Xi are just the data given to you. For instance, if I have my xi's to be a, b, c, and d, for instance, these are my x1, x2, x3, x4. It depends on I. If I is 3, you are referring to this term. So these are the data given to you. N is the number of data, 1, 2, 3, 4. In this case, n is equal to 4. Then x bar is the mean. It means what? This plus this plus this plus this divided by n. That is 4. That's the mean. Mean is constant. It doesn't change. What else? That is all. So, I would like to take this, break it down, and show that it can be expressed in terms of the other formula to the right-hand side. So let me start with the expansion. If I have x minus x bar whole squared, forget about the I know this should be xi's. What is the expansion? The expansion would be the first term squared, that is x squared, minus this minus. If it is plus, use plus. This is binomial expansion, remember. 2 is constant, times this. It will be x bar. Then plus x bar, that is the second term, squared. Yes. But remember, we have a summation here and also divide by n. So we can equally take the summation of the whole of this, also divide by n. The same thing. One thing you should know is that, I repeat, mean is constant. It doesn't change. So for instance, if I want to take the summation of maybe 1, it means what? 1 plus 1 plus 1 plus 1 plus 1. So if it is the summation of mean, it will be the mean plus the mean plus the mean plus the mean, maybe up to n. So instead of this, you can write it as 1 times n. Yeah. 1 in n number of times. For instance, if n is 10, it means 1 plus 1 plus 1 plus 1 after 10. So you can simply say 10 times 1. Even if it is 2 as a constant, it means 2 plus 2 plus 2 after 10, which is equivalent to 10 times 2. So since I know that mean doesn't change, first of all, let us distribute this summation. You know, summation of sum is also the same thing as sum of summation. So this is the same thing as summation of the first one squared minus 2 is constant, x bar is constant. So let me bring them first together. 2x bar. Then take the summation of that x. You see that? Then lastly, plus the summation of x bar squared. We are dividing by n, so let me divide every single term by n. Divide by n, divide by n, divide by n. And since 2x bar is constant, I can shift this n here. It doesn't matter. It will not change anything. Right? But what can you remember about summation of x divided by n? I have explained it earlier. This is nothing but the mean. You take all the items you have, you add them together, then you divide by the number. So summation of x divided by n will give us the mean. And already we have another mean here. So this will give us mean squared. So this is equal to summation of all the x's divided by squared divided by n minus 2 x bar. But this is another x bar. It will multiply this x bar. You have squared. Well, what is this? Summation of x bar squared. It means what? X bar squared plus x bar squared plus x bar squared n times plus n times of this x bar squared divided by n. Eventually, n and n will cancel. leaving only what? X bar squared. So we have minus 2 of something plus 1 quantity of something. It will give us negative 1 quantity of that thing. So finally, you can see that this can be written as this, which is summation of x squared divided by n. That is the first term. Minus 2 plus 1 will give us minus 1. So minus 1 x bar squared. Is this not the same thing as this? They are exactly the same. Therefore, it depends on the information given to you. You may decide to use this formula or this to find the variance of a given distribution. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye-bye.